API for Python, and we have quite a few modules implementing it. I'm going through the basics first, and will then head on to some more advanced techniques. So a bit about myself. I'm Marc Lemburg. I'm one of the core developers. I am on the board of the BSF. There's a members meeting today. If you want to attend that meeting, then you can talk to me and we can get you invited. I own a company called Eugenics. You may know the extension modules that we do, this MX Daytime or MX ODBC. And what we usually do is we do projects on an international basis and serve customers want to grow with Python. So this is the agenda of the talk. I have 90 minutes for the talk, which is way too much. I'm not going to use that much. And hopefully not bore you too much with it. I have 4 points. One is a short introduction into the DB API, then I'm going to follow up with the basic concepts behind the DB API. And then I'm going to show a few advanced techniques. If you have questions, just feel free to ask them. We have lots of time, so I can answer lots of questions. And then finally we have a discussion. If there are any remaining questions left. So let's start with the introduction. What was the motivation behind the Python DB API? Well, first of all, we wanted to have a standard interface to talk to databases. That was the most important part. The second important part was we wanted it to be easy to implement and easy to understand. The reason for that was that we wanted as many database modules as possible for all kinds of databases out there. We wanted to have high-quality modules, so the interface shouldn't have been too complex to implement in order to not introduce too many bugs. And we wanted to have all kinds of databases supported, even databases that don't really fit the model of the database API. There are a few things that are kind of misunderstandings about the DB API, especially from, I hear that a lot from people that come from other languages, like Perl, for example. Perl has this DBI interface, which is basically it's a central interface where you can plug in different drivers. What we have in Python is something different. We don't have a single API where you can plug in other low-level drivers. What we do is we provide the low-level API for all the databases, define that, specify that, and all the modules have to implement that API themselves. And then you can switch modules by just switching your import statement, in theory, let's say, and then adapt the SQL that you're using to another database, and then you can just use a different database. And over time, of course, because this is a very low-level kind of approach, there were many attempts to provide higher-level abstractions on that, which follows the design pattern that Alex Montelli mentioned yesterday. So instead of having multiple APIs, what you have is you have multiple levels of APIs. So if you want to use a more abstract level, then you can use one of these wrappers around the DB API, for example, SQL Alchemy, to have a more abstract view on the database. In general, there are 3 or perhaps even more different kinds of ways of doing this. One is a very common one is to have a SQL wrapper that takes off a bit of the load of having to write SQL every time you want to run a statement against a database. Another very popular one is the ORM, the Object Relation Mapper. That basically takes care of mapping the database tables and rows in the tables to objects in Python. And it also provides ways of writing SQL in a more Pythonic way, let's say. I'm not a particular fan of these ORMs because I like to write SQL just straight. It gives me more flexibility, more control over what's happening, and it's easier to optimize. But many people are very happy with these ORMs, so this is something that is very popular nowadays. Alchemy is probably the most popular ORM we have currently in Python. And lastly, you have the object database wrappers, which are basically implementations that try to provide an object interface on top of the database. So you don't really see the SQL, you don't really see the tables and rows, you just see objects coming from the database. You can compare that to the ZODB that you have in Zope. For the ZODB, there is a wrapper that takes all the ZODB interfaces and maps them to databases. So you can have a database underneath instead of a file storage. So how did all this start? The DB API has a long history. It started in 1996. It was one of the first attempts in Python to have a general standard, and it was also the first attempt to have something like a PEP sort of. So we had discussions, we had a design paper going back and forth on the mailing list to design the API. And it was all started by a US company called eShop. eShop was founded by Greg Stein and Bill Tutt. Does anybody know Greg Stein? No? He was at the time a very, very active Python core developer, and he wrote lots of stuff. He was helped on the Windows APIs that Marc-André continued to maintain. So the Win32 stuff that you have in Python, the iWin32 now it's called, was in part written by Greg Stein. They wrote the ODBC module for Python because they wanted to have their software, which was an eShop implementation, well, just a shop implementation. Nothing special nowadays, but back in those days it was very special. It was one of the first implementations that you actually had, and the company got bought by Microsoft later on. So they needed a database interface, and he decided to use ODBC for that, and that's also the reason why the concepts that we have in DB API map very naturally to ODBC. And again, ODBC is a general standard for interfacing to databases, so that's sort of like a perfect fit. Now the DB API 1.0 is a very good start for working with databases, but it has some caveats, so we needed to fix them. And we had a few years of discussion on the mailing list about all the different features that needed to go into the second edition of the DB API, everything that, all the things that were not so good in the first version of the DB API. So we had the DB API version 2.0 in 1999. And the module that we wrote, MXODBC, was one of the first to implement that. Nowadays there are lots and lots of other modules implementing that as well. And it's still the current version of the DB API, so it's one of the most stable APIs that we have in Python. It hardly ever changes, but it does get extended. So we have many modules implementing that DB API now. So we have lots of things to choose from. You can choose from different levels of implementing the DB API. You can choose from different extensions that they implement, because of course we were aware that the DB API would implement everything that a particular database could possibly support. What we did when designing the API was we designed it in a way that we made it possible for the module writers to extend the DB API. That was perfectly fit, and it was also something that we wanted the API, the module implementers to do. Now, over time, these extensions developed, and we had several databases implementing more or less the same extensions, and so we decided to standardize those extensions. So DB API 2.0 evolved by introducing new extensions to the DB API and making it support more things in a common way, so that all the extensions that were written for a particular purpose, they all implemented the same, basically API, attributes, methods, etc. For those particular databases that support that feature. Now, with the arrival of Python 3, we're probably going to have to have a new version of the API now, because there are some things, like for example the difference between binary data and text data, that are not well defined in the DB API 2.0, because at the time we didn't have Unicode. So we're going to need to address that. We also want to have more flexible data type bindings. We have the database world of data types, and we have the Python world. And sometimes they don't really match in a perfect way. So you want to have a way to customize that mapping, and you want to introduce some kind of way to provide a type mapping that you as implementer of an application can then adapt to your particular needs. And some of these extensions that I talked about, we want to make that part of the standard so that all the DB API 3.0 compatible modules will have to implement them. So what do we have nowadays? These are a list of very common modules that are used and maintained, actively maintained, and very visible nowadays. So for MySQL, we have MySQL DB. For Postgres, we have Tagliatelle 2. For Oracle, most common used interface is ZX Oracle. Then we have SQLite, which is part of the standard library. So the interface, DB API interface is MySQLite. And we have these MX ODBC modules for doing ODBC stuff, and we have MX ODBC Connect for doing client-server interaction with ODBC. So you can separate the clients from the servers, and that's all the communication stuff and the complicated things. So that was a short introduction. Do you have any questions? Yes?
The Python 3 database modules that are out already, what interface are they using?
As far as I know, there's only one database module actually written in a way that makes it work in Python 3, and that's the CyclePG one. The CyclePG for
I thought I saw, I haven't tried them, but I thought I saw Postgres one on MySQL.
Yeah, Postgres one. I'm not sure whether you can MySQL one. I haven't heard about that, but I know that the Postgres one was ported. I'm not familiar with it.
Right, so those are using the version 2.
Those are still using the version 2 standard, but of course they have already made some adaptations to make it work with Python 3. There are not many things that need to change there. It's basically just the way that you deal with text and the binary there.
Yeah.
In the DB API, we already have something, a special kind of way of telling the database that this is binary data, and so it's rather natural to make that mapping.
When's it likely that the version 3 standard will be there?
It's probably going to take a while. Because things, in general, things on the DB sync list, which is where all this happens, they tend to take a while. People are not really much in a hurry, because most of the people on that list actually use these modules in production. And Python 2 is still very much used in production, so they're not really that much interested yet in Python 3, which is why things take a little longer. But we're going to start working on it and discussing it, and it's going to take maybe a year or so, and we'll have the 3.0 version. Okay, basic concepts. We have two main objects that you have in the DB API. One object is called a connection object, and the other is a cursor object. The connection object basically wraps the connection to the database, so enables you to talk to the database. It also has things that deal with the transactions, and we'll come to that later. And the second important one is the cursor object, which makes it possible to execute SQL statements against the database and get results from the database. So first, let's look at the connection objects. Connection objects logically wrap the database connection. So if you want to talk to a database, you first have to establish a connection. You do that by calling a constructor for the connection object, which is typically called connect with a lowercase c. And then you have three parameters. One is the data source name, or the database name. Then you have username and password. What you get back is a connection object, which you can then use to do all the other stuff. Some extensions implement other constructors as well, which are more flexible in their particular field. Some use URLs or something similar to URLs to connect into a database. For example, SQL Alchemy has chosen that approach. So it makes it very easy to talk to different databases using that kind of approach. The connection objects are not used for running the actual SQL statements. That was something that was possible in the DB API 1.0, but was considered not a good idea. So we actually removed that feature again to 2.0. Instead, you should use cursor objects for that. Okay. Doesn't want to move to the next slide. Okay, there you go, transactions. Right, that's another important aspect of connection objects. They deal with transactions. Transactions are something very useful when doing database work. They provide a way to implement a very high level of consistency within the database. So what transactions actually do is they group statements into logical parts, and these logical parts can then be either committed to the database, so you make them permanent in the database, or you can roll back, so you can undo all the actions that you did in a particular transaction. So you have a block of statements, and you can execute all the statements, and while doing that, it'll look for the application, it'll look like those statements have already been committed to the database, but in reality, that's not what's happening. So you get a local view on the database for that particular connection. You can work in that local view, but other people connected to the same database won't see your changes yet. And only when you commit those actions that you did, those changes will actually be written to the database in a permanent way so that other users can see them as well. And that's very useful because obviously applications have bugs or the user errors, or there are certain constraints that are not that don't match what's defined in the database, and the actions that you're taking on the database fail for some reason, and then you can just roll back, and everything gets undone, which is very handy. Because otherwise, you'd have to keep track of all the things that you do in the database, and it may sometimes be very difficult to do that. For example, if you want to say you want to delete everything that has a certain value in a column. In a huge table, and you don't know in advance which rows are actually going to be deleted. So it's very difficult to do that in the application. And the database makes it very handy to just use transactions for that to handle these changes. There's one thing that you have to be aware of. It's not all databases support transactions. For example, the early releases of MySQL, they didn't support transactions at all. So you had what's called autocommit. So basically, you issue a statement and it gets immediately written to the database. So there was no way to undo these things. Nowadays, MySQL does support transactions, but it's still something that you should, when you decide on using a particular database, you should have a look at whether that's supported or not, or whether you have to make any changes or settings in the configuration to enable those. So this is a short view of the API provided by the connection objects. First of all, you have to establish a database connection, so you have to call the constructor. Then you have transactions. Transactions get implicitly started when you connect to a database. So whenever you connect, it starts a new transaction. And then the database waits until it gets one of the two next methods. One is called rollback, which rolls back the transaction, and immediately starts a new transaction. Or you call commit, which does the same thing except that it writes the changes permanently to the database. And then, of course, you have the close method, which then frees all the resources that you have attached to that connection. And it's good practice to always call close. It's also possible to just have garbage collection deal with the close, because when a garbage collection collects the connection object, it will automatically run this close for you. It's better to do that explicitly because the close can raise exceptions, and you might want to report them to the user. The close will also implicitly call a rollback. So anything that you haven't committed won't go into the database. The second important object is the cursor object. How many of you are aware of how tables, or this terminology, let's say the terminology that's being used in relational databases? You have tables. You know what cursors are? Yeah, only a few. So this basically works like a table in Excel. So imagine a table in Excel. You have different columns, and then you have a cursor, and the cursor in databases always maps to a complete row. So it's not a single cell; it's a complete row. And everything that you do on databases returns tables. And then if you want to move in the results that you get back from the database, you move this cursor from the top row down, all the way down to the end of the table. Probably should have put a picture here. So that's where this term cursor comes from. So it feels like a cursor that you have in a spreadsheet. And the name is a bit strange because you use this cursor object also to execute SQL statements. I'm not really sure where that name came from. It's very old. It's probably from the 70s or so. So just got continued. Sorry? Comes from COBOL, yeah. So it may look a bit strange. It is a good name for dealing with results. It's not a good name for dealing with executing SQL statements. What cursor objects do is they provide you direct access to SQL. So you can run execute on the cursor object, and you can write straight SQL, and just goes to the database and gives you the results back. And you can also do lots of other things with cursors. They provide access to metadata and a few other things. I'm not going too much into detail about the DB API. If you want to read up on all the details, you should go to the PEP index and look up the PEP 249 for the DB API 2.0. So the main method that you have on cursor object is the execute method. So with execute, you can pass in any SQL statement and it'll get executed on your connections. The cursors are always closely bound to the connection objects where you create them from. I'll get to that on the next slide. If you want to pass in parameters to the SQL, a very common mistake is to put in the parameters into the SQL statements themselves, which is a very bad idea because you can do all sorts of things, all sorts of bad things. Like, for example, you can have your SQL grab the table if you manage to get those parameters formatted in a certain way. And that's called SQL injection. It's a very common way of getting at private data nowadays, on websites especially. For the DB API, we have a different mechanism to prevent that. And what we do is we have a second parameter where you can pass in a couple of parameters that are needed for your SQL. And then instead of putting the parameters directly into the SQL, what you do is you put binding parameters, and we'll get to that on this slide. You put binding parameters into the SQL, for example, a question mark, or sometimes it's also a %s, or say a :1. It depends a bit on the database. That part is not specified in the DB API. We do specify the ways of doing that, but we don't explicitly define how to write these binding parameters. And by doing so, by putting those binding parameters into your SQL, you prevent this SQL injection attack. Because what you do is you pass in the SQL with the parameters, and you mark the places where the parameters should go, and you pass in the parameters. And the database will then take those two and put them together in a way that makes it impossible to do SQL injection. So it's a very good idea to use the second option here, using the binding parameters to pass parameters to the database. Right, so you've executed some statements, so you select on a cursor. Now you want to get at the result set, which is the temporary table that the database is created for you in order to fetch the results. And in order to fetch the results, we have fetch methods. We have 3 of them on the DB API. One is called fetch1, obviously just fetches one row. Then you have fetch many. You pass in a parameter, how many rows you want to fetch from the database. And you have fetch all, which gets all the results. Depending on what kind of size of result set you're expecting, it depends on which API you're going to use in your application. Sometimes it's a good idea to do a batched approach. So you say you get rows at 100 per batch. Sometimes it makes more sense to just get them all if they're not too many and then fit into memory easily. It's a trade-off because every time you call a method on this object, you have a round trip on the network. So you go to the database, you ask the database, will get me the next 100 rows, it comes back with 100 rows, and this network latency that you experience there, that's going to be a major hit in your application. So if you want to do fast database interaction, then you should try to get as much data as possible in one go. Provided it's not, if you have a huge data set, like you have 1 million rows that you should fetch, of course you can't fetch 1 million rows in one go. It'll probably not work out. Okay, so let's look at the API again. Cursor objects are created on the connection. So you have a cursor method on the connection object that you call. The cursor is then bound to that connection. If you close that connection and you still have the cursor around, the cursor will stop working. It will raise an exception every time you do anything in the cursor object. If you close the cursor, the connection will still remain open, so that won't affect the connection. And you can have multiple cursors open per connection. It's also possible to, for example, have multiple cursors in your application that are alive and that you can use in multiple parts of your application with one connection. And that's sometimes useful because there's a caching mechanism built into the API that makes it possible to execute the same SQL statement over and over again, and it'll then only prepare that SQL statement. Prepare means that the database will compile it into a data access plan in the database, and it'll only do that once. And if it finds that you're calling the same cursor object with the same SQL statement again, then it'll just reuse the database access plan, and you basically then skip this preparation step, which makes things a lot faster. That's very useful if you do, for example, bulk inserts. And if you do that a lot in your application, it makes sense for every single SQL statement that you have to have one cursor object open. It's very handy and makes things run much faster. We also have a more direct way of executing multiple SQL statements. If you know that you have just one SQL statement, say an insert, and you have a long list of parameters that you want to insert, a long list of rows that you want to insert into your database, you can use execute many. So what you do is, again, you use the bind parameters. You pass the SQL with the bind parameters to the execute many, and you pass in a list of parameters to the execute many. And the database will then take those two and execute them in one go, which is a lot faster. Then we have the fetch one, fetch many, and fetch all, and of course we have close method on the cursor. Again, the close method is something that you should do explicitly because it may raise exceptions, and it also frees resources in a controlled way. So it's a good idea to do that. Any questions?
At what point does the result set get destroyed?
Yeah, that's a good question. It gets destroyed once you call close, obviously, and it also gets destroyed if you call execute again.
Okay, so when you do a fetch one, that will get the next.
Yeah, can you all hear that, or should I repeat the question? Yeah, that's okay.
So when you do a fetch one, that will get the next item in the result set.
Yes.
It's a way of going back, or random access into the like a seed.
With the DB API, we don't have any ways of going backwards in the result set. We do have an extension for that, though. We have a scroll method in the DB API as an extension, so you can actually scroll back in your result set to a previous entry, and then start reading from there again. But the fetch methods themselves, they're just top to bottom.
So when you do a fetch all, after that action, the result set is still using a system resource.
Yes, it's still using resources, but if you call another fetch method after that, you'll get an exception. Telling you that the result set is
Okay, but it's still using a system resource.
It's still using resources. Yes.
So is that until you do the next query on that cursor?
Yes. There are also ways to, let's put it this way, there are certain database modules that implement extensions for doing that more explicitly. For example, in MXWC, because we know that this fact, we have added a new method, which is the method for freeing the result set. If you know that you're not going to use it anymore, but you still want to continue using the cursor.
Is that going to be standard in 3?
Yeah, it depends on discussions. But it's probably a good thing to put into the standard because it does use a lot of resources, and you have the results at twice basically. Once in your driver and once in your Python application.
Yeah.
Okay.
Is there any mechanism with a snapshot that you can restore the state of the cursor before you close the connection, and if you do the connection again, you want exactly the same set you had before to finish something, even if some records are missing or additional records are there.
Right, so
missing one you cannot.
I'm just going to repeat that. The question was whether it's possible to have a snapshot of the cursor object, so then next time you connect, you have a way of getting back to the same cursor object. It's not possible. There was another question here? Yeah.
Can you use connection to cursors
You can use connections as context managers. So, for example, if you want to, if you know that you have a certain number of statements that you want to run, you can have with and then the connection object, and then in that with block you can have all your executes, and it will take care of the rollback and the commit for you. But doing that is not necessarily a good idea, because you usually want to have more control over when the commit and the rollbacks happen, and it may not necessarily be a good place to have it hidden in the context manager. For example, what you typically want to do is you want to, when you get an exception, what happens in the context manager, when you get an exception, the exception itself will propagate further up. But the context manager will already have closed your connection or your cursor. And in that case, you cannot access the information on the cursor or connection anymore. So if you wanted to error reporting, there's no way to get at that information anymore because it's gone. So it's usually better not to use context managers and make the rollback and the commits explicit after you've got all the information that you want to put into your log message, and then you do the close and the commit or rollback, whatever you need. If you're already committed, the close basically cannot fail, because the close will just do a rollback, and if you don't have anything that changed the database in between those two, then nothing can happen. But you might still get for example, network error. Yeah, because it's possible. It's not very active, but it's possible that the network connection just closed down in between those two calls, so it might still happen. Okay, so let's proceed. This is an example session of how to use the DB API. So it's very straightforward. First you import your module, then you connect to the database, you get a connection object, you open the cursor, you run a few SQL statements on the cursor. In this case, I create a table, a test table, insert some data into the table. Then I do a select on the table. I fetch all the rows into a list of rows. What you get back is a list of tuples. So you get one tuple for each row in the table in the result set. The tuples are ordered in the way that you define in the select statement. And because I'm not doing any connection commit, I'm just if you put this into a .py file, then it'll just use garbage collection. collect the cursor object, it will collect the connection object, so there's no commit there, so there won't be any changes to the database. So this is a great way of testing this. And then if you want to go to production, what you do is, you correct the title. No. What you do is you insert your commits and your rollbacks in your code, of course. So you do the same thing again. You, for example, you create the test table, you commit that change, then you do the inserts, you commit those changes, then you do the execute. For the execute, you don't need to do any commits because you're not changing the database, you're just querying the database. In some very rare cases, that select may actually cause some trigger to run. So depending on how your database is set up, it may still change the database, but it's a very rare case and it's usually not a good idea to do that. But anyway, you just get your results and you do it close and then you can actually start and all the changes are all again. Yes, we're going to get to that later on. It's well possible. You can have multiple cursors. You can have multiple cursors for like doing many different inserts and multiple cursors for doing selects. Have them all open at the same time. Whether the database will actually support that is another question, and you have to check with the database. Not all databases support having multiple cursors open. Not all databases support having multiple connections open to the database. So it really depends on the database. That's not something that's within the scope of the DB API. The DB API just says this is the way to do it. Whether the database can actually handle that case is a different story. So you have to check that. So by the way, something else I wanted to mention. For some databases, certain statements that you execute, they need to be run within a single transaction. For example, anything that creates tables will usually have to be, or often have to be run in a single transaction. So the database won't let you, for example, insert anything into the table before you run the commit on it. I would say that it's actually a deficiency of the database that you're using there, because some databases are well capable of this. Some databases you can even drop a table with a million rows in it, and if you don't do a commit, it will just restore everything. But there are other databases that don't allow this. So you need to check whether it's possible or not.
If the database doesn't support transactions, will the commit raise an exception?
No, it'll just run through. The rollback will raise an exception.
The rollback will raise an exception?
Yes, because if you have auto commit and change the permanent anyway, you can't roll back, so you get an exception. Right, that was the section about basic concepts. Any questions? There are also some things that I don't mention in the talk. If you want to learn more about those things, you should have a look at the PEP 249. It mentions all the other methods and attributes that we have on the DB API. Okay, some advanced techniques. So let's first repeat what transactions are all about. Transactions logically wrap multiple statements into logical recovery. We have two methods for them. We have the commit and the rollback. And while this may seem very straightforward, there are a few things that can happen in reality that makes dealing with them sometimes a bit harder. One is called transaction isolation. This is about the question, who will see my changes and when? So let's say you have an application that's using multiple processes, or you have multiple users running a client application and talking to a database server. The question then is, if one of these processes talks to the database and for example, inserts some rows in there, whether the other connected processes and applications will see that change immediately, or whether they will see it only if you do a commit, or there's the question of what happens to the result sets that they may have open. So let's say they're doing a query on all the rows in the database. Will that result set on the second client, will that see the changes that the first client has put into the database already? And And that's called transaction isolation in database terms. This is something that's database dependent. Some databases allow to configure this. There are multiple ways of dealing with the problem. You have, I'm not going to go into details, you have things like dirty write or dirty read, so you can have results that change during the operation. You can have rows that you insert in your transaction in the database, go immediately to the database, and everyone else will see them, even though you haven't committed them yet. But those are not really good ways of running the application. And in some cases, that might be needed if you have more control over everything that's happening in your database, and it makes things run faster. But usually it's better to just stay with the defaults that you have in your database, which usually means that anything that you write to the database will only get seen by other clients after you do commit. The second thing that's important is database logs. Database logs is something that the database basically does for you. It means that you can log certain parts of your database, tables or rows, against changes by other processes. So consider, for example, you have one client application writing into a table or inserting rows in the table, and you have a different application reading all the rows from the table or getting information, embedded information, like the number of rows in a certain table. In that situation, when you write to a table, the database will usually log that table and not allow any other writes to the table. And if you want to read, for example, the number of rows that you have in the table, of course, one process is currently writing to the table, and the other one wants to know how many rows you currently have in the table. So the second application will have to wait until the first application is done with all the changes and is done with commit. And that's what's called database log. So you run a SQL statement and it logs until the first application is done. There are various different scenarios where this happens. It's even possible to have deadlocks, which means that both applications that you have running, talking to the same database, they basically log each other. This happens if you have complex transactions. So you have multiple statements on all the transactions. And say you have two tables that you're working on. One application writes to table 1. The second wants to read from table 1. Or let's say the second writes to table 2. And then both applications want to read the count of number of rows from the exception. Anyway, you have the first application writes to table 1, the second application writes to table 2. The first application then wants to have the count of the number of rows in table 2, and the second application wants to have the count of the number of rows in table 1. And then you get a deadlock, because the writing to table 1 will have logged table 1 for that application, and writing to table 2 in the second application will have logged table 2. And so when both applications want to fetch the count, they're deadlocking each other. And that's something that the applications cannot resolve, because they have to call the commit. But the execute doesn't come back, so you cannot call the commit. So the database usually implement a timeout for these things. Or they are more clever and can detect these cases and then give you immediately an error saying this is a deadlock situation. You better do something about your program. Right. This is something that's not being dealt with the DB API. I'm just mentioning this, that these things can happen. Of course, the various databases, they each have their own way of dealing with these logs. Many of the logs are set implicitly by the database, but you can also set them explicitly. So you can say log this table or log this row. You can also even say log just these particular rows that I'm currently updating and just leave the rest alone. There are many ways of dealing with this, but it's database dependent, and if you want to port between different databases, or you have to deal with different databases right from the start, then you should be aware of this. And you probably need to make changes to the application in order to work around these things. Another advanced technique is two-phase commit. Has anyone heard of two-phase commit? Yes, just a few. Two-phase commit is something that you need in distributed transactions. A distributed transaction is something where you want to talk to multiple databases. A very typical example is the bank transfer. So what you have is you have two databases. You have one database that has the accounts where you want to debit from, and another one that has the accounts where you want to credit to. And if you implement the transfer, the bank transfer, of course the transfer should only succeed if both the debit and the credit actually work out. Now, if you just have one database, that's not much of a problem because you have these transactions. You can just open a single connection, and you can then just execute your queries, the inserts, and the updates. And if something breaks, then you simply get an exception and everything is fine. If you have two different databases, you have two connections. So you have two transactions running, and the two transactions are not coupled. So if something fails on one transaction, it's not immediately going to fail on the second transaction as well. So you can end up perfectly with a situation that you have updated one database but not updated the other database. And to solve that, there's a concept called two-phase commit, which is not a perfect solution to the problem, but it's a reasonably good one, let's put it that way. There's still situations where this can fail, and where you still end up with this inconsistency, but in most cases it'll work out. So what's being done is you have the two phases. You have the first phase where you prepare the commit. So you tell the database what you want to do. The database checks whether it's possible to do this, and at that time whether it will succeed, and it signals you back whether the SQL that you want to run there would actually get written to the database without an error. In the second phase, you actually commit those prepared executes that you have there. Of course, this only gets done if all the different participating databases in the first phase have reported back that the commit that you're going to do is actually going to succeed. And that's where it may fail, because in that short time period between those two phases, there may still be some situation which then causes the second phase to fail. And then you have a situation where you still have these inconsistencies. But that's already a very good way of doing things. Did you understand that? If the second phase fails, you just get an exception, of course, but then recovering from that situation is going to be difficult, right? Because you don't, well, there are ways to figure out which transactions failed, which databases failed to actually do the commit, but in general it's a bit difficult to undo everything again. Yeah, it's just something that is advanced techniques. So you really have to look at your particular use case there, and you have to deal with that particular use case. There's no general way of doing this. The concept can also be extended to other things, and that's being done a lot in, for example, in banking or in large database installations. Large database installations usually have databases in multiple locations, and because the network connection between those two locations, for example, can be flaky, what they have is they have queues. For example, MQ series is an implementation that implements queues. You can write your data into those queues. The queues have transactions as well, and you can then be sure that the data actually gets from A to B and gets committed on the database that you have sitting in B. can do the same thing with files, with FTP uploads. FTP uploads is something that you often have to do if you deal with banks or with data providers. They usually use very, not very modern techniques to do data transfer, so they don't have APIs, you just upload something somewhere and then things happen. To manage this whole thing, there's something called a transaction manager that you have to install. It's not part of the DB API, it's completely separate. And the transaction manager will then coordinate all these different transactions and also report any problems to you. In the DB API, we've added a few extensions for this, so you can set up these two-phase commits rather easily. The methods are called TPC underscore and then begin and commit these things. You'll have to look in the tab for the details on these. The whole API is closely designed after the XOpen XA API, which was invented for this particular purpose. Any questions on this? Next one, schema introspection. The database schema is just a more complicated name for just saying, well, what's the design of the database look like? So what table names do you have, what column names do you have, which data types do you have in your columns, these things. And there are some cases where you don't know the schema of your database when you connect to it. For example, if you have an application that implements a database browser, the database browser won't know how your database looks, so it needs to find out which tables you have, which rows you have, which columns you have for data types to display. There is a very simple way of doing this, provided you know the table names. You can just do an empty select. Empty select is down here. It's you do an execute, you do a select star, which gets you all the columns in your database. And then you do where 1 equals 0, so it doesn't return a result set. But what you get is you get an attribute field as part of the DB API. It's called cursor.description. And that attribute provides information about each and every column in your result set. And it includes the name of the column, it includes the data type, it also includes the length information, for example, and various other information. Again, details, please get into that. So that's a very simple way of doing things. Then you have more advanced methods of doing these things. You can go to the system tables of the databases and then just get the information from the system tables. Of course, this is database dependent. For MXODBC, we've exposed what's called the catalog methods. ODBC is a general standard for databases. Of course, this particular problem with the schema introspection exists not only in Python, but basically in all applications that have to do with databases. So for ODBC, Microsoft added these catalog methods, which allow you to query all this data from the system tables in a consistent way. So, for example, if you want to know the columns, information about the columns, you have this .columns method. You can just get all the information about your columns from the database that way. So that makes it easier. Some other modules implement these things as well, but I'm not sure how the database specific modules deal with this. It's likely that if you're using a database specific module, then you probably know what the system tables are anyway. You just query those directly. If you use SQL Alchemy, for example, it will do part of the work for you and also provides methods to get this data. Right, next one. Multiple result sets. In some cases, it may be necessary to get not only one result set, but to get multiple result sets from the database. And this may seem strange because you only do one select from the execute. But, for example, if you call a sort procedure, which is a function that's being run in your database, in the kernel, then that sort of procedure may very well generate multiple result sets to report different things back to you. And of course, you need a way to jump from one result set to the next. So what we have is this next method on the cursor. And what you do is you first read your first result set until you're done, then you call next, then it jumps to the next result set, and then you can continue to read the next result and so on. Very simple kind of approach, works very well. Yes?
Go back to an earlier question. When you go to cursor on next, skips the next result set. Does that destroy the original?
Yes,
So if you did a cursor dot next when there is only one result set,
you'll get an error. It says, or you'll
but will it
choose the
freeze
original.
the
We have
original?
to check that. It'll when you have multiple results, it'll definitely destroy the first result
Yeah.
set. Yeah.
If you only have one,
If
if
you
you
only have-
cursor dot next, presumably you get an error. But does it destroy when you have? Is it a way of doing three? In other words,
It does the three, yes. So this is an example of doing this. So you have a call of a start procedure, my statistics procedure. Then you read the first result set to do a fetch all. You just get all the data from the first result set. You call cursor next, and then you can, with the next result set, you can get all the other data. Then you close, and then you have all the result sets right back into Python. Again, this is something that not all databases support. You have to check that. Some databases don't want to have multiple results sets because some procedures. There are other ways of dealing with that. But it's something that's very handy sometimes. Right. I'm pretty much through with my talk. So time for discussion. Any questions about the DB API in general, specifically? Do you have any other techniques that you would like me to talk about? Yes, you have the operations on the cursor are always top-down. Yeah? So you first get the first result set, you move through all the rows to the first result set, then you call the next, you go to the next result set, and again you scroll down to your second result set, and so on.
So when we make the cursor next,
Yes?
I put start I reference the next tool.
The cursor stays the same. It's the same object. Yes, yes. It's not that you don't get a new object. It's the same object.
Okay.
It's just that the cursor, yeah, it moves down, and then if you take this analogy of the spreadsheet, what happens is that first you read the first sheet in your spreadsheet, and then you call next moves to the next sheet in your spreadsheet, and then you read there, and then so on. Yeah? Here. Any other questions? No? Thank you. Hope you learned something.